Good morning, class. We are looking at college algebra practice test number 4, module 4, covering chapters 7 and 8. Here's chapter 7, systems of linear and nonlinear equations. This is the second one. So we have the following system. This is a system of nonlinear, as you can see. This is of degree 2. 3x squared minus y squared equals 12, x squared plus y squared equals 16. And we have learned a methodology for systems of equations that are linear. We basically follow the same method. We can clearly see that if we add these two, they will cancel out. We get 4x squared equals 28 if we add the left side and the right side. We divide by 4. X squared is 7, and x is plus minus square root of 7. Now we use one of the equations, for example, the second equation, and we plug in, and because it's being raised to the power of 2 plus minus will result in the same thing. So this will give us 7, and subtracting it from 16 results in 9, and y is plus minus 3. Now, please understand you have to write in pairs, and this would be 4 pairs as follows. Negative square root of 7 with negative 3, negative square root of 7 with positive 3, positive square root of 7 with negative 3, and positive with positive 3. That's how it works. So I hope everybody is okay with that. Now, it's really a good practice to check, always check. So I'm not going to check all of them, but I'm going to show you one of them. For example, we go to, by the way, how do we check it? We've already used the second equation to come up with the answer. So checking with the second equation makes no sense whatsoever. You must check with the first equation. So you are going to put one of those pairs, for example, this one, into the first one. So check with equation number 1. That's the most important thing, knowing which equation and why. So plug it. So what happens? This one, when you square it, becomes 7. So 3 times 7. This one, when you square it, becomes 9. This negative outside remains. 21 minus 9 is 12. Yes, we check mark, meaning that did work. And that's the idea, everybody. So it does check. Everybody's happy, and we are done. Now, needless to say, you have to check the rest of them too, but they're very straightforward and simple. Now, what about an inequality? Graph the system of inequalities. You graph only one of them at a time, okay? And then put them together. So if I want to graph this one, I need to find the line first. If I want to do this one, the same thing. So I'm going to come up with 2 lines. And that is a borderline for each case. For this one, I'm going to need 2 pairs. So I'm going to go with the x and y intercept. If x is 0, y becomes negative. If y is 0, x becomes 1. This one, if x is 0, y is 3. If y is 0, x is 2. So those are the intercepts. I'm assuming nobody has any problem finding those. So those are the two lines. 2x minus y equals 2. 0, negative 2 is here. 1, 0 is here. This is the line. 3x plus 2y equals 6. 0, 3 is here. 2, 0 is here. If you also for the second one, use the one. Those are the intercepts. So what we do, we pick a test point, a point that doesn't belong to the line of interest. And if 0, 0 doesn't, would be the best choice. So by the way, why am I changing this to a dashed line? Because it doesn't have the equality. Whereas the blue one is solid. Solid line, dashed line. So we pick 0, 0 because it's the easiest point and it works. We are going to put this back into the original inequalities for each case. For example, if I put it here, 2 times 0 minus 0 less than 2, 0 is less than 2, it's a true statement. And because that's a true statement, I'm looking at the red line, the shaded region would be this side of it. In fact, let me do that with red. So because 0, 0 works, this would be the solution for the first inequality. In fact, if we just had this one, we would be done, end of this. But for the second one, we do the same thing. We plug in 0, 0 as a test point, everybody. If I put 0 here, I get 3 times 0, 2 times 0. 0 is larger than or equal to 6. No, that's a false statement. So for the blue line, 0, 0 doesn't work. So if 0, 0 doesn't work, the side that contains 0, 0 is out. So you go with the opposite side. You shade that one. And as you can see, the two colors, red and blue, come together right here. So this is the region. And take a look at this one. So I'm going to erase my work so it becomes clear. There are, when you have two lines, there are 1, 2, 3, 4 regions. One of those 4, in this case, happen to be a solution. Graph the inequality y is larger than x squared plus 1. It works in the same manner. Whenever you have any type of inequality that you want to graph, first change it into equality. So graph this one. As you know, y equals x squared is a parabola. X squared plus 1 is a parabola that has been shifted up by 1 unit. So that's the graph where this point has coordinates 0, 1. Now, the way it works, first of all, this borderline is not included because we don't have an equality. You have to make it dashed, number one. Number two, you pick a test point. The way it works, it's inside or outside the parabola. So pick a point that it's not on the parabola. For example, 0, 2 is somewhere here. If it works, this is the answer. If it doesn't, the outside is the answer. It's that simple. So you pick a test point and you check it out. If I plug in x is 0, I get 1 and y is 2. So 2 is larger than that. Yes, it is a true statement. What does it mean? It means this point works. So everything inside works. So you're going to shade the inside and make sure the borderline is dashed. So that's the test point. Shade the region inside. The parabola itself is not part of the solution. So that's how equality and inequalities are graphed. Again, in the case of inequalities, first you change them to equalities. Make sure the borderline is included or not based on this. If it has a equality, it's included. If it doesn't have equality, it's not included. You pick a test point. Any point will do as long as it's not on the line or on the graph of a function, in this case on the curve. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he's got 80% and 40% acid solution. How many liters of each in stock solution should he mix to prepare a 10-liter mixture? As the name indicates, this is a mixture problem, everybody. This is called a So what happens with the mixture problem when you mix two things, the total volume, size, weight, depending upon what you're dealing with, will remain constant. You can't change that. So we go with a table like this for a mixture problem. The strength of the solution would be 80%, 40%, and we have the mixture. So we write those numbers in the form of a percentage or decimal. So this becomes 0.8, this becomes 0.4, and the mixture we want is 48%. Now, how much do we need? 10 liters of 48%. So we need 10 liters here. How many liters of each? I don't know. How about X and Y? So we are defining our variables. X liters, the same unit, of 80%, Y liters of 40% solution. Now, clearly this is one of the equations, X plus Y must add up to 10 liters. That's why it's called the mixture problem. But the pure or the actual amount of, in this case, acid, would be if it's 80% solution, only 80% of it is acid. So 0.8x, in this case, 0.4y, and the result is 0.48 times 10 or 4.8. So as I mentioned, this is one equation, x plus y is 10 liters, the volume is constant. The total pure amount is not changing, so these two add up because we are mixing them up, we are adding these two, and we get 4.8. We're done as far as the hardest part, which is setting up the equations, is concerned. Now, the next part is solving the system. And to solve the system, you have many different methodologies. For example, if you want to go with the substitution, in this case, we're going to solve for y. We get 10 minus x. So 0.8 times x plus 0.4 times y, which is going to be 10 minus x, equals 4.8. So this remains, this 1.10 cancel each other, becomes 4. This is minus 0.4x, and the right side doesn't change. We put things together. These two add up to 0.4x. Subtract 4, you get 0.8. Divide by 0.4, and you get 2 liters. Now, we want to make sure we have answered everything. If x is 2 liters, that means 2 liters of 80%. What should y be? If they add up to 10, y must be 10 minus 2. 8 liters of 40%. Now, please understand, I use the first equation to find the missing one. And I'm going to leave it for you to check. To check, you have to use this one. In other words, 0.8. Here's the checking, everybody. Let's quickly do that. This is important. 0.8 times x, which is 2, plus 0.4 times y, which is 8, is it equal to 4.8? And the answer is yes. This is 1.6, this is 3.2, they do add up to 4.8. It checks. So it literally takes a few seconds of your time to check your work. Make sure you always check your work, everybody. I can't emphasize this enough. How many liters of a solution that contains 15% chemical must be mixed with 6 liters of solution containing 10% chemicals to make a solution containing 12% chemicals? Again, you're looking at a mixture problem. So you need a table that says the type of solutions. In this case, we have a 15% solution, 10% solution, and a mixture. This is 0.15, this is 0.1. The mixture is 12%, 0.12. So we have 15% chemical and must be mixed with 6 liters of 10%. So 6 liters of 10%. I'll put it in order. So first I see the 15%, then I see the 6 liters, and then the 10%, and we need 12% here. That is the setup. So how many liters of 15%? About X, you are defining your variable. X liters. So if that is the case, what would be the total amount for the mixture? Add them up, X plus 6. What is the pure amount for this one? The product of these 2, 0.15 times X. What about this one? 0.1 times 6, which becomes 0.6. What about this one? 0.12 times X plus 6. And so basically, this is the equation. The two add up, 15% and 10% add up to give a mixture. So 0.15x plus 0.1 times 6 is 0.12 times X plus 6. So as I mentioned, this is 0.6, 0.12x, 0.72. I move this here. Subtract it from 0.15 and we get 0.03. I move this one. Subtract it from 0.72, we get 0.12. We get 4 liters of 15% solution. So pretty straightforward mixture problem. A plane can travel 800 miles per hour with the wind and 720 miles per hour against it. Find the speed of the wind and the speed of the plane in still air. Set up a system of equations and so on. You should define your variables, everybody. So we can go with X and Y, but it's easier to go with the initials. We let P represent the speed of the plane, W, the speed of the wind. We just use the initials. When we go in the same direction as the wind, if we are swimming, current, if we are in a boat, the speed of the current. If you are going in the same direction, the speed of the wind, the speed of the current will help us, will be added to our speed. If you are going against it, it's going to work against us. So 800 miles with the wind, that means P plus W is 800. 720 against, that means P minus W is 720. Of course, if you add them up, the elimination method, these two cancel each other. 2P is 1520. Divide by 2, and P becomes 760 miles per hour. If you put in the first one, the wind must be 800 minus 760, which is 40 miles per hour. And you can check it with the second one easily. 760 minus 40 is also 720, and that works. Admission tickets to the Braden River Little League All-Star Game cost $4. For adults, $1.50 for children. A total of 225 tickets were sold, and a total of $500 was collected from ticket sales. How many adult tickets and how many children's tickets were sold? We want to set up a system. Believe it or not, this is also a mixture problem. So we are going to set up a system as follows. Adults, children total, the ticket cost, the number, the total amount. So let's plug in what we have. Adults, $4. Children cost $1.50. Total of 25. This number, the total of the number of tickets is 225. We collected total money, total amount, $500. So how many adults? I don't know, you can say X and Y, or it's easier to go with the initials. I'm going to go with A, representing the number of adults, C, the number of children. Sometimes it makes it easier if you just go with the initials, everybody, because you clearly will remember how you defined your variable. So in any event, if that is the case, what is the total amount collected from adults for A? Collected from the children, 1.5 times C. This is an equation. This is the total number. So A plus the number of adults, number of children must add up to 225. And for A, 1.5 C, they add up to $500. Now we can solve it by any method. For example, the addition method, if we want to keep this intact, if we multiply this one by 4 negative, we can get rid of the a. If we multiply it by 1.5 negative 1.5, we get rid of the c. So let's multiply the first equation by negative 4. We get minus 4a minus 4c minus 900. And we're going to keep equation number 2 intact. We're not going to change anything. So we add them up. I want to make sure everybody has a chance of writing what they want. So when we add them up, these two cancel each other. These two add up to negative 2.5c. These two add up to negative 400. Divide both sides by negative 2.5, or change this to 25, change this to 4,000, and we get 160. And we do the division. Because I hope you see that 2 zeros corresponds to 100 divided by 4. 25 is 4. 4 times 40 is 160. And 160 is the number of children subtracted from 225. The number of adults would become 65. And of course, as usual, you really have to check. And the way it checks is with this second equation. So obviously a plus c is 225. That's what we use. Now you want to put it into the second equation, make sure you get $500. That's how you check this, everybody. One leg of a right triangle is 4 centimeters less than the other one. The area, 70 square centimeters. Determine the length of each leg, set up a system. Let's do the drawing. So this is a right triangle. The sides are X and Y, and by the way, that means one of them is the base, one of them is the height, because it's a right triangle. And the relationship is that one leg is 4 centimeters less than the other. So that means X seems to be smaller. So X must be Y minus 4. That's the meaning of the first one, everybody. The area is 70, and the area is 1/2 base times the height, where base and the height in a right triangle would be the two sides. So we have the first one, X equals Y minus 4, and now The area is 1/2 x equals 70. So that's the system we are going to solve. First and foremost, let's get rid of the fraction. So let's multiply both sides by 2. Xy becomes 140. Just because we want to get rid of the fractions. That's the only one. No, that's the only reason. Now, for this one, I can replace the x with y minus 4. So we get y squared minus 4y is 140. Move this. Now we want two numbers. The product must be negative 140. The sum must be negative 4. The answers are negative 14 and positive 10. So there are two possibilities. Y is positive 14 or y equals negative 10. And of course, the same units. This is square centimeters, this is centimeters. Because we are dealing with dimensions, negative is out. So y can only be 14. And if you replace it here, 14 minus 4 is 10. So one is 14, the other one is 10. The dimensions are 10 and 14 as the final answer, everybody. So it's really straightforward, everybody. And as always, you can check it. And of course, at this point, the checking takes place with the second equation. Half of xy must be 70. If you multiply these two, 140, and divide by 1/2, multiply by 1/2 or divide by 2, you get 70. So that works. The sum of three numbers is 1/5. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. Find the numbers. So the very first thing you have to do when you come across a system of equations like this is to define your variables. So we are going to say, let the first number be x, the second number be y, the third number be z, any variable of your choice. Now we go back. It says the sum of the three numbers is 105. X plus y plus z must be 105. So we are going to do one by one. The third, that means z, is 11 less than 10 times the second. The third, z equals, means equals, 11 less than what? 10 times the second. 10y minus 11. Twice the first. So here's the first one. Twice the first, 2x, is equals 7 more than 7 plus 3 times the second, 3 times more. So each equation is taken care of. Now we are going to solve this. So there are different ways of solving this. What I want you to notice is the following. The last one has x and y only. The second one has z and y only. And the first one has all of it. So one easy way is to do the following. First of all, let's call them equations 1, 2, 3, so we know which we're dealing. Equation 1 has all of them. Equation 2 involves z and y, and 3 is just x and y. If I go to equation 1 and replace the z with equation 2, so z becomes 10y minus 11, then this equation has x and y just like the third equation. So let's do that. So equation 1, I'm going to replace the z. So I'm going to write x plus y plus z. Z is 10y minus 11 equals 105. When I do that, I get x plus 11y equals 116. And I'm going to say this is equation number 4. I give it a name, equation number 4, everybody. Now, equation number 4 we just made up has x and y. Equation number 3 has also x and y. So we are going to put equation 3 and 4 together and work on it. So equation 4 is this. X plus 11y is 116. Equation 3 is what we had. Now, how do you solve this? Again, one easy way you notice 2 times x is this one. This doesn't have a 2 times x. If I multiply this one by 2, it gives me 2x plus 22y equals 232. And then I can replace the 2x with 7 plus 3y. Again, this is one easy way. This is not the only way. Normally, you bring x and y on the same side and you get rid of one of them. Since this is solved for not for x, but rather 2x, I'm going to multiply the top by 2. So if I multiply it by 2, this becomes 2x, this becomes 22y, this becomes 232. Now, this is 2x. I'm going to replace it with 7 plus 3y. So this, I replace it with 7 plus 3y. I can add these two to 25y, move the 7, subtract it from 232 to get 225. Divide by 25 to get y equals 9. Now, if I go back to one of the original equations, equation number 2, z is 10y minus 11. Because I have y equals 9, we're going to plug in 10 times 9 minus 11, and that gives me 79. So we have the y, we have the z. We can go either to any of those, the first one or the third one, and find the missing x. So if you go with the first one, x plus y plus z equals 105. Y is 9. Z is 79, making it 88. Subtract from 105. X is 17. And you have 17, 9, 79. And since we used equation 1 and equation 2, you really have to check with equation 3. 2 times x, that means 2 times 17 is 34. 7 plus 3 times y, 7 times 3 times 9, 27 also is 34. So you have to check, and it doesn't take long before you can find the answer. So this is doing it by hand. I want to remind you using matrices. So if I go back to the same question, everybody, again, we did define our variables. We did come up with our equations. And now all we have to do, use matrices. The augmented matrix would be 1, 1, 1, 105. Now I'm going to change this so you see what happens here. This one, I'm going to write 10y minus 10 plus z equals minus 11. And this one, I'm going to write 2x minus 3y equals 7. So this would be 1, 1, 1, 105. This would be, there's no x, 0, negative 10, 1 minus 11. And this one would be 2 minus 3. There is no z, 0, 7. You put that, let me erase my word. You put that into a calculator. And then if you do RREF, reduce row echelon form on matrix A, this last column is exactly what you've already got as your answer. So this is the final answer.